Knowledge Nexus.
Welcome to Knowledge Nexus, where we unravel the intricacies of technology. Today, embark on a journey through the world of binary numbers, the fundamental building blocks of our digital universe. Binary numbers, the language of computers, are quintessential to all things digital. But what makes them so vital? Unlike the familiar decimal system, which uses 10 digits from 0 to 9, binary numbers only use 2, 0 and 1. This simplicity makes them the ideal language for encoding data within the electronic circuits of computers. Imagine a world where machines understand only two states, on, represented by 1, and off by 0. This duality is the essence of binary, translating vast amounts of information into processes our machines comprehend. We'll delve into how binary works and why it holds such paramount importance in computer science today. As we proceed, visualize streams of binary code illuminating screens, silently driving the tech that powers our lives. Stay tuned as we delve deeper into the nuances and applications of this numeric system, laying the groundwork for the chapters ahead. Let's dive deeper into the intriguing world of binary numbers. Binary numbers serve as the foundational language that systems use to communicate, being at the heart of digital technology. But what exactly are these binary numbers? Binary numbers are part of a base 2 numbering system that relies solely on two digits, 0 and 1. Picture a world where all digital data, from simple texts to complex images, is translated into a series of zeros and ones. To truly grasp binary numbers, we must dive deeper into bits and bytes. Imagine a bit as the smallest unit of data, holding a value of either 0 or 1. A collection of 8 bits forms a byte, which can represent a wide array of information. This simplicity is the secret to the digital magic behind computers and other tech devices. Now, let's embark on the journey of counting in binary. Start with 0, then 1. But what comes next? When we run out of digits, we move to the next column, similar to how we add a 1 in the tens column once we surpass 9 in the decimal system. So 2 in binary is 10, 3 is 11, and so on. Understanding this basic counting principle is essential as we proceed to explore more complex features of the binary system in subsequent segments. Let's move forward to discover how binary numbers translate into our everyday digital experiences. Welcome to Counting in Binary, where we embark on a fascinating journey. Imagine a world defined by just two digits, 0 and 1. That's the foundational language of computers, binary. In this segment, we'll unravel the beauty of binary counting, which may seem mysterious at first, but is elegantly logical. Let's begin with counting the simplest numbers, starting from 0. With each step, discover how just two numerals can represent values as diverse as any decimal number. Picture each click advancing us from 0 to 1 to 10 as we ascend through binary digits. Visual examples will guide us as we explore binary counting up to 15. Before you know it, you'll be fluent, effortlessly translating complex concepts into recognizable patterns. From toggling switches to intricate computations that power our digital age, binary is paramount. Let's delve deeper and reveal the mechanisms that make binary indispensable. As we move forward, this understanding will enrich your appreciation for binary, setting the stage for our next topic, converting dynamic decimal numbers into expressive binary form. Now, let's delve into the fascinating process of converting a decimal number into its binary counterpart. This might sound complex, but it's straightforward once we break it down. Picture this. You take your decimal number and repeatedly divide it by 2. Each time you divide, note the remainder, which will be either a 0 or a 1. These remainders build our binary sequence from bottom to top. For example, if you start with the number 26, you divide by 2, getting 13 as your quotient and 0 as your remainder. You continue dividing each new quotient by 2, collecting remainders at each step until you reach 0. By reversing the sequence of remainders, you reveal the binary code for the original decimal number. This visual transformation, supported by step-by-step illustrations, helps clarify the concept, making it not only learnable, but also engaging. Mastering this technique illuminates just one of the many interconnected ways the binary system serves as the backbone of computer science. Let's continue our journey by exploring the reverse process of converting binary numbers back to decimals, expanding our understanding even further. Now, let's convert a binary number back to decimal. We'll unravel this mystery step by step, exploring each digit's hidden potential. Imagine a binary number like 1011. To convert it to decimal, we harness the power of base 2. Start from the rightmost digit, working left. Multiply each digit by 2 raised to the power of its position. For 1011, that's 1 times 2 to the 0, plus 0 times 2 to the first, plus 1 times 2 to the second, and finally 1 times 2 to the third. Add them together, and you get the decimal number 11. Visual aids will guide you through each step of this transformation, making the process intuitive and clear. Understanding this conversion is essential, as it bridges the gap between the binary code driving our computers and the numbers we use daily. This newfound insight brings you one step closer to mastering the fundamental language of technology. Get ready for the next segment where we'll dive into binary arithmetic operations, expanding your skill set in this digital domain. Let's explore some fascinating arithmetic operations in the world of binary numbers. Binary arithmetic is the cornerstone of all digital computations, seamlessly performing tasks we often take for granted. Here, we'll dive into the basics of addition, subtraction, multiplication, and division, all executed in the binary system. To start, let's look at binary addition. Much like the decimal system, binary addition involves carrying over numbers. For instance, adding 1 and 1 in binary gives us 10. This is because 1 plus 1 equals 2, which is represented as 10 in binary. Now moving on to binary subtraction, which follows the concept of borrowing from the next higher bit, much like subtracting in base 10. When you subtract 1 from 10 in binary, the result is 1, echoing the simplicity of base 2 arithmetic. Multiplication in binary relies on shifting bits and is remarkably straightforward. Multiplying by 2, for example, simply shifts the bits to the left. Finally, let's tackle binary division, which follows a logical flow of repeatedly subtracting and shifting similar to long division in elementary math. Understanding these operations not only improves problem-solving capabilities, but also enhances comprehension of how digital systems process data. Our grasp on binary arithmetic lays the groundwork for exploring more advanced technologies that power modern-day computing. In the next segment, we'll explore how these binary concepts manifest in computer hardware and software. Stay tuned as we delve into the real-world applications of binary numbers. Binary numbers are at the heart of our digital world, seamlessly operating behind the scenes, propelling technology. Let's delve into the real-world applications of this fascinating numerical language. Every piece of computer hardware, whether it's your trusty laptop or an industrial server, relies on binary to function. It speaks the native tongue of software, transforming human intentions into digital actions through zeros and ones. In essence, every operation starts with a binary decision. Digital communication, too, is a marvel that hinges on binary codes. When you send a text message or stream a video, binary numbers rapidly encode and decode information, ensuring that what you receive is accurate and instantaneous. These exchanges happen across oceans of data pathways, made possible by the simplicity of binary. Moreover, think about data storage, a cornerstone of our tech-driven society. From storing treasured photos on the cloud servers to vast databases containing years of research, binary numbers reduce data to its most efficient form, ensuring sufficient room for all the information our world generates. Binary, though simple in representation, is extraordinary in function, powering today's advancements from artificial intelligence to quantum computing. As we transition to the next segment, we'll explore why a profound understanding of binary knowledge is pivotal in navigating the digital world. Stay with us as we uncover how binary knowledge empowers innovation and technological mastery. As we bring this journey through binary to a close, let's reflect on the key insights we've uncovered. Understanding binary numbers is not just a technical skill, it's a cornerstone of navigating our increasingly digital world. From basic counting to the intricate architecture of software and hardware, binary knowledge enables us to engage deeply with the technology that shapes our daily lives. Within this base 2 system lies the power to comprehend modern technology. Every byte, every piece of data, every interaction in our digital communications hinges on this simple yet profoundly essential knowledge. Binary is the lens through which we decode the digital language, a language that defines the capabilities of computers and the internet. As we summarize these concepts, recognize that knowing binary is a critical bridge connecting us to all digital advancements. Stay with us as we move to our final thoughts, where we'll invite you to continue this exploration of computer science on our Knowledge Nexus channel. Thank you for embarking on this enlightening journey through the world of binary numbers. As we conclude our journey through the land of binary, remember how essential these concepts are in today's technological world. We hope this video sparked your curiosity in computer science. Thank you for watching. If you enjoyed this insight into the world of ones and zeros, don't forget to subscribe to Knowledge Nexus and share this video with your fellow tech enthusiasts. Keep exploring the wonders of binary and embark on the thrilling path of digital discovery. Until next time, keep learning and evolving in the universe of numbers.